Okay, these are the 8.3 notes, inverse trigonometric functions, pages 4, 5, and 6. And we are going to focus now on the inverse cosine function. We're going to kind of follow the same path we did with inverse sine. We're going to look for patterns and see if we can make sense of why we restrict the range for cosine so that we can make it a function. So we're going to start by reviewing what our cosine function looks like. So at negative pi, cosine is -1. At negative pi over 2, that's the bottom of the unit circle, it's 0. At pi, it's 1. At pi over 2, it's 0. Again, at pi, we've got -1. So as we go to graph this, before when we graphed it, we graphed the period from 0 to 2 pi. Looked a little different, just started up at the top, went down, ended up at the top. Here again, we're sandwiching that 0 right in the middle of the period. So we're going to graph this from negative pi to pi. Okay. Here's the million-dollar question, is this function one-to-one? And so we take a look at a horizontal line. We realize that a horizontal line is going to hit this more than once. So no, this is not a one-to-one function because it fails the horizontal line test. And so we're just going to make that note here. Hopefully we're color-coded enough at the top so that this makes sense. Okay, so there is one thing I want to point out as long as I've got this unit circle down here at the bottom. Okay, so our cosine, let's take a look at how this works. If I take a look at these top two quadrants, in quadrant 1, cosine is positive. In quadrant 2, cosine is negative. Okay? So we hit all of the possible values of cosine, positive or negative, between 0 and pi, or that 0 to 180. If we were to continue below here, we've got quadrant 3, where the cosine is still negative. Quadrant 4, where the cosine is positive. All of those are going to be repeats of the values that we see in quadrants 1 and 2. So again, we really don't want to do more work than we need to. Okay. We want to make sure we streamline this as much as possible. So now I want to create the table for the inverse cosine function, and I am going to do what we did with sine. I'm going to take the table from above here, and I'm just going to swap my x and y values. So my x's become that -1, 0, 1, 0, -1. My y's, I got negative pi over 2, 0, pi over 2, and pi. Do these values make a function? Again, no, because if I plug in 0 for x, I could get either negative pi over 2 and pi over 2, and I really don't want to have to work very hard. That's not how a function works. I should be able to give you just the function value 0, and you should be able to tell me what the output is. Okay? So we are going to go ahead and see, we got pi over 2 and pi up this way, negative pi over 2 and negative pi down this way. And to start, before we answer this question about how we can define this as a function, I'm going to go ahead and graph what I have above. So at -1, I've got negative pi. At 0, I'm at negative pi over 2. At 1, it's 0. At 0, it's pi over 2. And at -1, it's pi. Ooh, I missed. Make it bigger. Okay. So there's roughly my inverse cosine function. You notice this is not a function. Sorry, this is my inverse cosine from the table above. Not a function because it does not pass that vertical line test at this point. So a couple things I want to point out. I can look at this part up here. My domain is -1 to 1. My range is 0 to pi. This hits quadrants 1 and 2, right? My range of 0 to pi. So down here, my domain is -1 to 1. My range, -pi to 0. This is going to hit our quadrants 3 and 4. So there's duplicates here, right? I don't need both halves. I just need to hit half the circle to get all of the cosine values. Since we like keeping things positive, we are going to focus on quadrants 1 and 2. So we are going to define inverse cosine so that it returns a value between 0 and pi. So we're going to define it this way. Must return value. So our output between 0 and pi inclusive. We can use those. That restricts our inverse cosine to kicking out function values that fall or lie in quadrants 1 or 2. And so every time you see an inverse cosine, just know your answer is going to be in quadrant 1 or 2. We don't want anything that is fallen in quadrants 3 or 4. Okay? That's what we're saying right down here. The domain is -1 to 1. The range, 0 to pi. Okay? So let's see what that looks like. Here we've got inverse cosine of 3 pi over 2. That means we're really trying to answer the question about where is the cosine x square root of 3 over 2. Okay, we know that happens in quadrant 1 at pi over 6, which is 30 degrees. I'm going to crank them both out just for the practice. We also know that's in quadrant 4 at 11 pi over 6, or 330 degrees. Again, our output should be restricted to quadrants 1 and 2. So this value, 11 pi over 6, does not work. If we're considering the range as well, 11 pi over 6 is bigger than pi. We probably want to include the range here in degrees too. So that's 0 to 180 degrees. And our 330 degrees lies outside of that range. So the inverse cosine of square root of 3 over 2 is pi over 6, or 30 degrees, depending on how you're being asked to generate an answer. Inverse cosine is -3 pi over 2. That happens in 2 places on the unit circle, at 5 pi over 6, which is 150 degrees, and in quadrant 3 at 7 pi over 6, which is 210 degrees. Same as with our first one, we want the value that falls in quadrant 2. Our quadrant 3 value, 7 pi over 6, is bigger than pi. 210 degrees is also larger than 180. So this value does not work. Do you have to show that every single time? No, definitely not. I do want to make sure you're comfortable with the fact that yes, cosine is positive square root of 3 over 2 at 2 places on the unit circle. In terms of inverse cosine, though, there's only one place that we use. So there's only one appropriate output. 12, arc cosine of 1. Where is the cosine 1? That happens at 0 degrees. Okay. So here we're asking for the expression in degrees. Where is our cosine negative 1? That happens at 180 degrees. That makes sense that the bounds of our domain match up with the bounds of our range. Okay. Inverse cosine of negative 3.5, again, that falls outside of our domain. And so this has no answer. Not possible. Okay, so let's streamline this little. Let's streamline this a little. Number 13, we want the inverse cosine of square root of 2 over 2. We know that the only place that happens in quadrant 1 is pi over 4, or 45 degrees. We want the inverse cosine of negative square root of 2 over 2. That puts us in the second quadrant. Inverse cosine of negative square root of 2 over 2 is 3 pi over 4, or 135 degrees. Just the reminder, the domain, negative 1 to 1. The range of cosine is 0 to pi.